This lecture is about sensitivity and specificity. You often hear people describing tests using sensitivity and specificity as if they're telling you everything you need to know. In this lecture, we'll explore the true meaning and the limitation of these terms. Once you have a 2x2 table, the calculations are straightforward. Sensitivity is calculated from the first column of patients who have the diagnosis, and specificity from the second column, patients who don't have the diagnosis. So sensitivity is calculated by taking the number of patients with a true positive test, that's A, and dividing by all the patients who have the condition according to the reference standard, that's A plus C. So the equation is A divided by A plus C. Specificity is calculated by taking the number of patients with a true negative test, that's D, and dividing by all the patients without the condition according to the reference standard, that's B plus D. So the equation is D divided by B plus D. Let's put some practice numbers into the 2x2 table to see how this pans out. You can see that 200 patients are pregnant, of whom 198 have a positive test, so sensitivity is 198 over 200, or 99%. Similarly, 250 patients are not pregnant, of whom 240 have a negative test, so specificity is 240 divided by 250, or 96%. Put this into practice by imagining a woman coming to see you requesting a pregnancy test. The first thing to say is that the test is imperfect, so we won't be able to say with 100% certainty if she's pregnant or not, but we will be able to give her a probability of pregnancy. Let's say the test is positive. How likely do you think it is that she's pregnant? Here are three options: 99% likely, 96% likely, or I don't know. Think about this for a moment and pause the video if you need more time. Remember, sensitivity is 99% and specificity 96%. Many people think that the answer is 99% corresponding to sensitivity, or perhaps 96% corresponding to specificity, but the correct answer is actually I don't know. The truth is that neither sensitivity nor specificity gives enough information to decide on the probability of this woman being pregnant. To explain this, look at the 2x2 table again. Remember that sensitivity tells us about women in the first column who are definitively pregnant, but we don't know if our patient is pregnant, so the answer can't be based purely on the sensitivity. Similarly, specificity tells us about women who are definitively not pregnant, and in the second column, so the answer can't be based purely on the specificity either. What we do know about this woman is that she has a positive test and is therefore in one of the boxes in the first row. We just can't tell which one. So clearly the true answer must have something to do with both sensitivity and specificity. We'll come back to this concept when discussing Bayes' theorem, but at this point it's worth reiterating that simply knowing sensitivity and specificity, unless they're 100%, is never enough to determine the probability of a condition. You often hear people discussing sensitivity and specificity as if they are the last word on test accuracy. Hopefully this exercise illustrates that they are in fact just the starting point when we want to discuss the utility of a test.